So picture this. Your dashboard is glowing, showing 100% code coverage. Your manager's thrilled. Every single one of your unit tests is green. You feel pretty much invincible. Until a critical bug slips into production. How? Well, welcome to part 1 of our series. Today, we're going to pull back the curtain on that green illusion and introduce you to your new best ally, mutation testing.
You know, we've all been there. It's that awful, sinking feeling when you realize all those metrics, all those beautiful green check marks, they gave you a totally false sense of security. You did everything by the book, but the system still failed. That how is the million-dollar question, isn't it? And it points to a huge misunderstanding of what our tests are actually telling us.
And right there, that's the heart of the problem. Code coverage, it's kind of like a roll call in a classroom. It tells you which lines of code showed up for class, but it has no idea if they were actually paying attention. It doesn't tell you if your assertions are strong enough to notice when something goes wrong. It just confirms the code ran. To build software that's truly resilient, we have to go deeper.
Okay, let's dive right into this illusion. Because to get past these surface-level metrics, we need a technique that does something pretty radical. It actually tests the quality of our tests themselves. And that technique is mutation testing.
So what is it? Honestly, it's a beautifully simple, almost devious idea. A tool like p-test goes into your code and starts deliberately breaking it in small, very subtle ways. It creates these broken versions called mutants. Then it runs your existing test suite against each and every one. Now, if your tests fail, congratulations, you've killed the mutant. But, and this is the real aha moment, if your tests still pass, even though the code is broken, you've just found a serious blind spot.
And you know, this requires a completely different way of thinking about quality. It's not just about defending against bugs we've already fixed, it's about actively hunting for weaknesses we don't even know exist. This is what I call the quality duel. It's a fundamental shift in mindset.
Look at the shift in perspective here. Traditional regression testing, that's purely defensive. It looks backward, and it asks, did we break something that was working fine yesterday? But mutation testing, it goes on the offensive. It's a proactive strike that asks a much, much tougher question. If a subtle bug were introduced right here, right now, is your test suite even capable of noticing? It assumes things will break, and it challenges your test to prove they're actually up to the job. So how does this really work in practice? Well, by creating these tiny alternate realities in your code, these mutants expose the assumptions you didn't even know you were making. Let's look at a couple of classic examples. First, a simple if condition. Every if statement has two worlds, right? The true path and the false path. A mutant might just flip that condition. Now, if your test passes, no matter which path is taken, it isn't actually verifying the logic at all. Second, and oh boy, this is a big one we see all the time in Java, a method that returns a list. That's not just one path. It could return null, it could return an empty list, or it could return a populated list. Those are three totally distinct realities your production code could face. And this just nails the danger perfectly. If your test only asserts that the returned list isn't empty, a mutant that changes the return to null will survive. Your test will keep on passing, but in production, that exact scenario causes a null pointer exception that brings your entire application to its knees. Mutation testing finds that wide open door and forces you to write a test that slams it shut for good. Okay, so the tool has run, it's created all this chaos. Now what? How do we even measure the results? This is where we get a score that actually means something, a score that reflects the true strength of our test suite. You see, when PyTest finishes its work, it generates this fantastic report that tells you exactly where your tests are strong and, more importantly, where they're weak. It all boils down to a few key outcomes that give you this crystal clear picture of your test quality. First up, the one you always want to see, killed. This is a win. This is a victory. It means the tool changed the code, your test ran, and it correctly screamed, hey, something is wrong here, and failed. Every single killed mutant is proof that your test is a guardian actively protecting that piece of logic. Next is the one that should really get your attention. Survived. This is a red flag. A survived mutant means the code's behavior was altered, but your tests just sailed on by, completely unaware. Each one of these represents a potential bug that your test suite is currently blind to. This right here, this becomes your to-do list. And all of these outcomes get rolled up into one single powerful number. I really want you to think of the mutation score as your truth metric. While line coverage tells you how much code you touched, the mutation score tells you how much of that code is actually protected. It's simple. You just divide the number of mutants your tests killed by the total number that were created. A low score means your tests are just spectators watching the code run, not guardians protecting it.
Now, there are a few tools out there that can do this, but for modern Spring Boot applications, the choice for me and my teams is crystal clear. We're going to be focusing on PyTest, and for some very, very good reasons.
So why PyTest? First off, it's actively developed and maintained, which is absolutely critical in our fast-moving ecosystem. It's also built for performance. It's way faster and more scalable than older frameworks, which makes it actually practical for large, real-world projects. And finally, it offers a much smoother integration process, which you'll see firsthand in our next explainer. It's really the professional's choice for a reason.
Now that you've mastered the theory of killing mutants and understand why p-test is the industry standard, you're ready for the next step. Join me in part 2, where we'll get our hands dirty and actually configure p-test inside a Spring Boot project. For the full code snippets and the complete step-by-step guide, be sure to check the Medium article link in the video description below.